application, stuff like that, you can try to work on these areas, which will be quite useful. Okay, so I will give you some pointers, some basic information on research needs. Okay, that's what we'll do. On Friday, if we are behind, that means if we haven't finished all of this by Thursday, second session, we will do some lecturing on Friday. Other than that, we will generally talk in terms of summarizing everything. You ask me questions, I answer if I know the answer. If you want to discuss or present what you know, you can always bring it up. Throughout these lectures, we'd like you to be interacting with me, because I don't want to be the only person talking. You can talk anytime, no problem. But generally, in Indian context, you will see all our students, our faculty, our staff, we are very hesitant to talk. Okay, if this is the same thing as American audience, everyone will have an opinion, and very strong opinion. Okay, so we can end up actually arguing for hours, which is good. That's the way you bring out your best. So even my students, they will keep arguing, or they will discuss and we'll talk. We don't want to show you every single thing like 2 + 3 × 5 is this much. We don't want to show that. They know how, you know how to do it. So I don't want to go over this whiteboard or screen how to do those simple things. You will do yourself. But the concepts are important. If you can capture the concepts, then I have done a good job. If not, I will go back very sad. Okay. The next thing we'll do is introduction. So, okay, that's good. So now, I'm so sorry, this is not so clear. Dim the lights for just 1 second, okay? Just a few front lights. Okay. Is it any better? Yes. Okay. So, okay. Can you hear me? Okay. So this is roughly the map of United States. Many people ask me, nobody would have heard of a place called Akron. So where are you from? You must be from somewhere in Odisha or something. Then I say, this is where Akron is. So some of you, or many of you would have heard about Pittsburgh. Some of you would have visited New York, or maybe Chicago. You must have visited some of these places. So if you draw a straight line, this is New York. Okay, New York is right here. Okay, that's Akron, that's Chicago. So we are exactly midway between New York and Chicago. So from here to here is about 500 miles. From here to here, 500 miles is about 2.2. That would be around 1,200 kilometers. Okay, 1,200 kilometers from here to here. Okay, so that's where my university is. I live slightly north of this place because that's an inner city. So inner city means trouble. Okay, so we will talk about composites. So what is the term composite mean to you? What does term composite mean to you? Perfect. That's the simplest possible definition. If you combine more than one material, can be 2, can be 3, can be 4, whatever, then we call it composite. That's a layman's definition of composite. So, by that definition, is wood a composite? Of course it is, because there is fiber in your wood that gives you the actual bending. You'll see sometimes the trees are bending like this, but they're not fully falling over, right? Why is that happening? Because there's fiber in there. That fiber is preventing the tree from falling over. And then there is lignin that combine together and they act. This is the key thing. They act together. Okay? So that makes it a composite material. So wood is a natural composite. So the fibers provide you strength, and the matrix, which is the cellulose, lignin, provides the, in a simple term, it's glue. It keeps them together. Is concrete a composite? Definitely, because at a microstructure level, you have so many different materials and they are all working together. Cement paste, you have coarse aggregate, you have fine aggregate, they are all combined. Once they harden, they work as a single unit. What about reinforced concrete? So slowly we are building on it, right? So this is concrete. Now we are saying we are adding a few more, one more item to the material, which is reinforcing bars. We place them in proper locations to gain the strength the way we want it to gain, and that's a composite material. So based on that, we can say a combination of reinforcement material in a matrix or binder material. So we started with saying, oh, if we add two materials, that's composite. That's what we started with, right? Then we said, okay, we want material which is, one is fiber, the other one is matrix, so, or binder. So those two, when combined, that's a composite. Okay, that's slightly one level better definition. So, in other words, we did not say that. We all know, we know that composites are composed of microscopically identifiable material. So if you cut a section and look under the microscope, you can easily distinguish between the different materials, okay? And at molecular level, they have distinctive component properties, which is self-explanatory. Generally mechanically separable. That means you can separate these mechanically. Can you separate the fiber from the cellulose in a tree? You can't. So that will exclude this definition. What about concrete material? Can you separate them? No, not possible. Same thing with reinforced concrete. You probably can, but the materials will lose its characteristics. So that way we will define it in slightly more detailed manner. So this is the latest definition of composites. It may look very obvious, but this is the current definition of composite. It says reinforcement fiber. So that's one component. So in your composite, in a structural composite, you must have reinforcement fiber, okay? In a polymeric resin matrix, so polymer-based resin matrix, where the reinforcement has an aspect ratio. Now we are adding more and more details. So we are saying the reinforcement has an aspect ratio. What's an aspect ratio? Aspect ratio is defined as, yes, length over the dimension. Okay? It can be diameter, it can have square cross section for fibers too. It won't be always circular cross section. So the dimension, that will give you your aspect ratio. So it has to be, the aspect ratio has to be adequate, or it cannot be overly long, to transfer the loads between fibers, and the fibers are chemically bonded. So we are adding so many conditions here. I think first we are saying the composite itself needs to have reinforcement, needs to have polymer, and then you have an aspect ratio requirement to be satisfied. Then we are saying the load has to be transferred between the fibers. If they don't transfer, that means all the fibers will pull out, right? You have matrix and you have fiber, and if the load is not transferred between the fibers through the matrix, the fibers will all pull out, okay? So we need to have that kind of load transfer, and the surface of the fiber needs to chemically bond with the matrix. If all these conditions are satisfied, we can call this a composite in structural terms. So it's a structural composite, okay? So 6 items are given in this definition. They need to be satisfied. So in this context, You can always correlate this with your reinforced concrete, steel reinforced concrete, which we are all familiar with, right? So in steel reinforced concrete, what all do we have? We have steel reinforcement for sure. Then we have concrete, which is like matrix. You can have fillers in concrete, right? Name one or two fillers. Silica fume? Yeah, so you have so many fillers. What about additives? Say that again. One additive. Admixtures, okay? So those are the kind of things you have in reinforced concrete. So we will have similar items in case of composites as well. Okay? So the reinforcement is the fiber. So what I'm doing here is I'm just introducing you to basics, that's all. It's almost common knowledge. You all know this. Just I'm putting a structure to what you already know. Okay? That's what I'm starting with very simple basic stuff. Then we'll move on slowly and build on this basic information. Okay. So our fibers actually carry the load. For perfect performance, you need to have continuous long fibers. You can make composites with small length fibers, that's possible. But it won't be effective or it won't be efficient. So if you have continuous fiber, that is always an advantage. So you get continuous load transfer from one end to the other end. Now, why is the fiber? Okay, I didn't say that, but I will say it now. The fibers are very, very strong. So let's say, to give you an idea, what do you think the diameter of a normal person's hair is? How many microns? 100. Yes, somebody said 100. I will take that. Of course, it depends on my age also, right? The older I am, it becomes thinner. But 100 is good. Generally, the hair, our hair, each hair, has a diameter of about 100 micrometer. Our fiber we'll be using in composites will be about 10, 15, 20 microns. Okay? Glass fiber is about 15 microns, 20 microns. So you get a feel for numbers. So you have hair which is 100 microns. You have a fiber, structural composite has only 20 microns. Okay? So material is very, very strong in a fiber form. In bulk form, it's not as strong. So, in case of glass, if you take a lump of glass, there will be so many air pockets, air bubbles. Some of them are quite visible. Some of them you have to look under the microscope to find out that there are bubbles or air pockets, right? So, when you draw fibers from bulk material, they become very, very strong. Why is that? Because at a very small diameter of 20 microns, the possibility of air pockets is smaller, definite. Okay? It simply snap rather than have an air pocket. Okay? So that's the reason glass fiber will be very, very strong in its fiber form because of the reduction in number of defects. There are other types of fibers like aramid fibers, which are polymeric fibers. This one is you get higher strength in fibers because of the alignment of polymer chains. Okay, those of you who are organic chemists or you're good at organic chemistry, you will probably understand it better than me. But just let's take it as it is. As we say, alignment of polymer chains are in the direction of the fiber, therefore it's much stronger in that direction because of the the polymeric chains. And then there are some crystalline materials like carbon and graphite. The alignment of the crystals is in the direction of the fiber length, therefore it's very, very strong in fiber form. Some of you probably work on coconut fiber. You look at a coconut, you don't really think that's strong, right? But it is strong. Actually, it is strong. So even whisker, that is like anything in very small dimension or diameter, if the diameter is very small, the fiber will have much larger strength. And strength is something we would like to have in our structures, right? We want our structures to be strong, and also, of course, there are other considerations, but strength is one of the primary considerations. So fibers are reinforcement having high aspect ratio, and ACI 440 is the primary committee that works with, or that's creating all these reports on fiber reinforced polymer. ACI stands for American Concrete Institute. So that 440 committee has about 8 or 9 reports. Almost all the information available throughout the world is generally represented in ACI 440. So they have it all combined, and it's a very good resource for advanced studies and to understand the common practice. So it defines fiber as a filament of material whose length is at least 100 times. So now they are defining it more clearly. So if the diameter is, let's say, D, and the length is 100 times D is the minimum length you must have in order for it to qualify as a fiber. Okay, so typically our diameter is, again, 13.13 millimeter, that's what they mention. And 100 times of that is whatever that is, 13 millimeter. So that can qualify as a fiber, structural fiber. And the strain within the matrix needs to be transferred to a series of fibers. So the force transfer is a requirement. Unless that happens, you really don't get any strength of the composite. Just like, I don't know if you have done any pull-out tests for concrete. So you're trying to pull out the bars. At some point, the bars will pull out. That means at that time, it cannot be used as a composite material. So because these fibers are placed in very predefined directions, the strength of the composite is also directional. That means it will be strong in the direction of the fiber, and perpendicular to the direction of the fiber, it won't be very strong. So what about resin matrix? It doesn't matter how good your fibers are, unless you have a medium through which there is load transfer, there is really, you are missing out on something, right? So fibers cannot be used by themselves. If you use just fibers, it is of no use. They will break, of course, and whenever you have smallest compressive force, there will be stability problems. So in compression, the fibers will never ever work by themselves. In tension, maybe, but not in compression. So matrix is needed to provide this kind of holding type of action for the fiber, and it's relatively rigid. If you see, the matrix is somewhat rigid when it is hard, and therefore it will give you stiffness. So stiffness is very important in case of stability, right? Whatever little compression is applied, the composite can become unstable, and if you have a matrix that gives some dimensions or some thicknesses, then it will be able to resist some amount of buckling tendency. And the fibers are protected just like your concrete. Concrete protects the steel reinforcement from environment. Fibers are also protected from environmental attack and corrosion. It provides some corrosion resistance. And of course, chemical and physical damage is also prevented. You will see in a later chapter, you will see that strength and stiffness of matrix is negligible compared to fibers. We'll talk about it later. So, the matrix is actually, it's completely chemically bonded to the fiber. That's how it will function. So that chemical bond is what gives you the ability to transfer load between fibers. Okay? And because the matrix surrounds the fiber and there is load transfer, you need to have both of those materials to work together to provide the actual strength. What about fillers? Fillers are generally used to reduce weight if needed, and the matrix, the resin material can be expensive, and of course you can provide fillers as retardants. That means they can provide some amount of fire resistance due to heat and flame. They can be used to reduce smoke and improve chemical properties and so on and so forth. One thing you have to take care in case of composites is UV radiation, exposure to UV radiation. So most of the composites are affected by UV radiation. Okay, so that's a very important aspect. So if it is directly under sunlight, after some time it will probably degrade, it will lose its integrity. So filler materials are generally low aspect ratio materials, roughly spherical in shape. Fillers are also known as particles. They are very small in size. And generally speaking, your composite materials will have smaller dimensions, so they will be normally thinner. So if you make anything very thin, what's the problem? Do you know what the problem could be? Stability becomes a problem. Okay, so it starts buckling and stuff like that. So because of high strength, you can always reduce the dimensions, but at the same time you are introducing something else, which is instability. And of course fillers are not reinforcement, and you already gave some examples of filler in concrete. Just like that, effects are accounted by modifying properties of the matrix, which is fine. Okay. So fillers can be organic, inorganic. You can read this yourself, but generally speaking, there are different kinds of fillers: calcium carbonate, calcium sulfate, and alumina, and so on and so forth. Okay. You can have spherical or hollow spheres of glass. That can be a filler. They need to be distributed uniformly. That's an important requirement. Creep, shrinkage, and tensile strength. You will see creep is a problem. Okay, so there are a lot of advantages of composites, but there are also many disadvantages. We'll talk about it in the next presentation. Shrinkage, you can improve the properties, particularly in creep and shrinkage, by using fillers. So you mentioned this. It's like in concrete we use silica fume, fly ash generally as fillers, and then additives. So sometimes, just like in concrete, so you can make concrete sleep, right? How long? Do you know what I mean? Sleep for how long? How many? Just guess. Guess. It doesn't matter. You may be wrong, I may be wrong. It doesn't matter. How much? 72 hours. Wow. Yes, that's a little bit high, but it's easy. Nowadays, they are able to sleep concrete for 24 hours, no problem. Particularly if you are placing concrete in a remote area, 24 hours is quite normal or quite common. 72 hours is slightly, I'm not aware of it. Maybe if you are sure, then I'll take it. You are sure it can? 48 hours you are able to sleep, make it sleep. Oh wow, very good. So that's how long, so it's like that, you know. So you can make it set very hard too, right? I mean, it's very fast, right? Right? I don't know, I'm not concrete expert, you are. So you can add polycarboxylate, right? And of course, let's not go there. There are a lot of problems with that, interaction problems with other admixtures added with polycarboxylate. Anyway, so you can make it set fast, you can make it slow down in terms of setting. Those are the things you do by additives, and you can do similar things with composites. Does it make sense? Now, there are also other items like dyes. You can put a nice logo, and you can dye with dyes. You can change the color of the appearance, like your computer science building here. It looks so nice. I thought it was precast. Is it precast? Does anyone know? The computer science building here. Is it a precast building? It looks like precast to me, but it looks really nice. You're not sure? Not precast? But it looks like a precast. Very nice. So you can do that kind of thing, and you can provide colored concrete, just like you use in dyes for coloring concrete. You can use dyes in composite. Releasing agents are important, just like your form oil, right? In your form oil, you know form oil, like if you have form work, you're placing concrete, you provide some releasing agent. Otherwise, it will be stuck to the forms or false work. Yeah? So it's just like that. You have to have some kind of releasing agent. Pigments are added for color, of course. So in summary, composites are a combination of reinforcement fiber in a polymer resin matrix, where the reinforcement has an aspect ratio that enables the transfer of loads. That's important, transfer of loads between fibers, and the fibers are chemically bonded to the resin matrix. That's what is the gist of this presentation. That's the summary of this presentation. Okay? Any questions? Do you have any questions?
How we can give the direction of the fiber?
Say that again.
How we can give the direction of the fiber in concrete?
We'll talk about it. In next presentation, I'll show you how that is done. I have some samples. I'll show you how you can define the direction of the fibers if they are two-dimensional fibers. Okay? Thank you. If I don't talk about it, please remind me. Okay? Thank you. Yes?
Is it permitted to use a fiber which is having the different aspect ratio?
It will not have, okay, let me put it this way. The load transfer is important, right? So if you have fibers with small aspect ratio, there will be pull out. And if there is pull out, there is no load transfer, and therefore they don't qualify as composites. So for structural action, you need to have minimum aspect ratio, and ACI has defined that to be 100. So you can easily get that kind of aspect ratio. For example, how many of you are familiar with fiber reinforced concrete? Quite a few, right? So in fiber reinforced concrete, there are different kinds of fibers, right? Some of them are really, really short fibers. They're like, they are not structural fibers. They're just for shrinkage reduction, right? And these suppliers, they'll come and say, oh, we'll reduce cracking. Buy this, put 2 pounds per cubic yard, or about 2 kilograms per yard or something like that. It'll solve all your problems. I don't think so, because they don't have the aspect ratio for the load transfer. They will never improve fibers. The small chopped fibers will never improve structural properties. Same thing here. Unless you have adequate aspect ratio, which is 100, minimum 100, It will not give you load transfer. Answer your question? Yes.
Dilatation silicone may be act as additives also in concrete.
I have at least 20% of this